Hi guys, today we are going to see the extension of the previous video. Uh, so far we have seen how to deploy the microservices in AWS EKS using the Helm chart, and also how to install the Istio and see the Grafana, uh, Kiali, Prometheus, the metrics around it, right? Today, I want to talk about slightly interesting topic, which is called the magic of Istio and Helm. So we are going little deep inside the Istio and show the power of it. Okay, so in high level, what you're trying to do is Istio is a service proxy acting as a intermediary or interceptor, right? That can add capabilities like automatic retrace, circuit breaker, service discovery, security, and much more, right? So it's a sidecar pattern, and since so it's like a proxy where you could do things so that you are not touching the real pod, but you get the uh, all these bells and whistles like a retry, circuit breaker, those kind of things using the proxy. And this default service proxy for Istio is based on the Envoy proxy, and we can do blue-green deployment and Canary deployment. So today I'm going to show you a demo of the Canary deployment, and Helm package manager helps to install all these YAML files together as a release. So first we'll see what is a Canary deployment, how we could do it very easily through the Istio, right? So what I did just now was I created the EKSCTL create cluster minus region minus name minus nodes and the node min, node max, and the node group name. So once I give these parameters, it took for 10 minutes and it created the cluster for me. I want to show you guys that the next probably 3-4 minutes I'll be keep on executing commands, but the commands are even in the previous video, it's the same kind of command. The first thing is we will be installing the corresponding utilities for the Istio, right, on the cluster. So first I'm just going into this directory where I have installed Istio 1.2 version, right? So previously I was using the PowerShell. I moved to okay, that's because of the Unix thing, right? So I have to get into this slash. I thought I did that. Hold on. Okay, so here, yeah, sorry. So from here, so I have both instructions of what to do for the PowerShell's way as well as for the Cygwin way. Cygwin is kind of really helpful because, for example, so to execute these kind of commands, the PowerShell, the for loop, and those kind of Unix shell script way, I cannot do it on the PowerShell easily. So, okay, created. Okay, so probably first I have to go to I have to follow the instructions carefully. I have to go to the directory first, yes. And once I go to the directory, then I execute the for loop. Then this is going to create you all the uh, corresponding Istio things gets created on the Kubernetes cluster. Right? It wants if I have to do it in the PowerShell, I have to do it in 5 steps. But here it's only 1 step. So that's why I went to the Cygwin, and it's pretty handy though. Okay, so now I'm going to execute this command. This is basically saying the template for the Istio, right? So all the binaries of the Istio is there now. So we are going to get the big YAML file. Okay, so once this big YAML file is created, now is the time to apply this Istio objects to the cluster with this kubectl apply command, right? It's going to create all these things for us. And now this command is saying For any pod I install, let the Istio injection also be enabled so that sidecar pattern is there for all the microservices what we are trying to install. Okay. So now Helm thing. Helm is also a very important thing because um, Helm is going to help you to install all these things at one release way rather than executing kubectl so many YAML file way, right? Um, it has two components, client side, where we have to create the Choco hem to get the client side of it, which I already had one time. But this one, every time I create a cluster, I need to execute the tiller YAML file. And then I have to initiate the service account in this thing. Okay, so now is our interesting thing. That's it. All the setup for the hem and the istios are all done. Now is the time to do our application, right? So I'm in the crash course master 12 Helm, and within this I have. So if I show you here, see this under this. Now you have all the for every microservice you will have the respective directories here. So first I want to execute in the same order. Okay, so first I'm going to do the rating. So catalog is a composite service which relies on the rating and the info. So first I'm trying to get the execute the rating time thing. So this is going to execute stuff. Now after that I'm going to execute the info thing. So this is going to create the info stuff, right? So it's creating the resources for it in the Kubernetes cluster. As usual, previously I was having only movie catalog. Now I created one more directory called movie catalog blue green, and this is where I have the special configurations for the blue green thing. I'm going to show you that, and I executed this once, so hopefully this name will work. Otherwise, I will change the name to Helm 1 or something. Yeah, so it creates. So now all of the three microservices has been created using the Helm chart, right? And I also want to show you how it works first. Then so first you have to see the ingress gateway. You have to say this. See, now we are getting this beautiful external IP address, right? So copy this, go back to this. I want to change this to the new way. Every time you create a new cluster, you get a different external address, right? So the elastic IP. So now, yes, you guys keep seeing it. Now you see there is something called blue version. So keep watching this. There's something called blue version. Blue version. Wow, there is no blue version. It's directly starting with the movie name. Okay. Green version. So hope you guys are understanding something. So the name lock stock is the name of the movie, and sometimes you don't have any prefix, and sometimes you have a prefix called the green version, then lock stock, right? And sometimes some again green version, right? Blue version. See, now the prefix is blue version. So we are seeing the three variations of it, right? So this is the magic of the canary deployment. So I'm going to switch into the what is a canary deployment. Okay, so first of all, how do I have this? Is like this is the same example which I keep showing it to you guys in other videos. So in this movie catalog resource controller, uh, before I actually, on this method, there is a method called get catalog, right? This is the method which I'm exposing the get user ID and so on. This is a calling the rating service first, and within the, then it's iterating, and within that it is calling the movie info service. So movie rating, for every rating it is calling the corresponding info and returning the catalog as a wrapper object. So that is why when you see here, you see this is the movie info all the way here. Okay, then here rating 3 is the rating info. Okay, then this is the container pod image. Okay, so this shows so from which pod it comes from. So this is the, so how do I able to see get sometimes blue, sometimes green, sometimes no, because I created 3 images. Okay, so probably what I did was, if I go into the github.com, I can show you that pretty fast. So once you guys see, this is nothing but a movie catalog service. Oh, this is the GitHub. No, I want to show you guys the Docker Hub. Sorry. So you should see there are 3 tag for the catalog. Previously, I was just having 2.2. Now, still the same 2.0 is there, which created a month before, which doesn't have any prefix. Yesterday, I created a blue release and green release with the same code base, just adding that extra prefix on the controller class, and generated the image, Docker image, and deployed it to Docker. So now I have 3 versions of it. So why I'm showing this? Because for Canary deployment, we are trying to show all the 3 application versions simultaneously. How that is possible? Okay, so there are some things where uh, first I want to show you the values.xml. This is the parameterized thing for the Helm, right? Usually you'll have an image. This is a good old image 2.0 without any prefix, and there is a blue image and there is a green image, right? So I have 3 images. So I have a separate tag for each one of them. All of them has point the same port number, node port, supplicas, and name. The rest of it, the movie catalog. So same thing, except the images are parameterized. Now, this is the same kind of YAML file. In previously, it was just having only one version of it, but now I have the same. First version is there, V1 version is there. Okay, and the V1 version is here, the blue image. Okay, so I'm using for the V1 version the blue image. Okay, then I have another movie catalog V2 version V2. Okay, so matching label. So these are all the labels are all still matching to the movie catalog only. All the labels matching to the movie catalog, but only the version is different. Okay, and now this is matching to the image is pointing to the green image. Okay, the rest of it is same. All of them is pointing to the same rating, the same info. Okay, and the last, the variant movie catalog version 3 is following the similar thing, but instead here it's using the image, which is a 1 month before, no prefix, right? And the service is the same way. So first you have to create how many variant of your service you want to show simultaneously to the load. Say right now the load has been distributed across these images. So for how many ever image you want to try it out, so you have to just put it in your YAML file. Since it's all Helm, it's all parameterized, so much easier as well, right? Except the image, the rest of it is almost same, and the name should be unique. So that's why this First one is catalog dash v1, second one is v2 slash v3. Okay. So now let me show you this one. Okay. So nothing changed on this. This is the gateway, HTTP gateway, which is nothing but a ingress gateway, which is of 80 HTTP. Okay, that's why the URL we are not giving any port. Since it's for listening on port 80, it redirects to that. So this is the same thing from the previous last video. Nothing changed on this. Okay, the real magic happens on the virtual service. This is the thing. This one thing what you have to see. Since the proxy pattern gives you this virtual service, now you are going to say prefix slash catalog. Okay, prefix slash catalog. We are saying the destination is going to be v1, v2 and v3. Okay, and what is v1 and v2 and v3? It's all being defined in the destination rule below. So name v1 is nothing but the label version v1, v2 is the label version v2, v3 is label version v3, which goes back to our microservices deployment where it knows the v1, v2 and v3. Got it? So the ingress gateway, now it's using the destination rule to send the traffic to the respective versions. While sending it, you could say what is the weight. So here is 30%, here is 40%, here is 30%. So that is why now you are getting the thing almost pretty evenly distributed. Now I want to show you guys probably v1, v2 and v3, correct? So I want to say probably 90% of the time it should be the blue, and 10% of the time the thing, and the 0% of the time should be for the no prefix way. Okay, so I'm just giving this way. So we just changed this. So what we should do now? So now we need to apply the Helm thing. Now instead of creating install, we have to upgrade, and we have to say this. Okay. So now what we are trying to do is we change the distribution and nothing else we change, just the distribution of it. So now let's see how the URL should not change. But what you're going to see is most of the time blue, now one time green. So 90-10, and you won't see any non-prefix. So the version 3 is the one which doesn't have any prefix, that you won't get now at all. So all by just changing and applying that one virtual service, Helm upgrade, you are going to see what happened, right? So now if you want to see what are all the things happened within the thing, you can see Helm history. So it's going to say blue, green, movie catalog, Helm history error. Okay, so did I do any blue thing? I think Helm. Yeah. So we have to give this name. Okay, whatever the name what we used to create. So this is the name. So now we are getting two versions of it. The first version is install version, and that has been superseded, and the second version has been deployed, and this is what this one. So if at all you don't feel like keeping this version, you can roll back to the previous version. It's just one command, and you can go roll back to that. That is the power of this Helm thing. Um, so um, so now one thing what we observed is this canary deployment through this. For example, if you are trying to have, yeah, one particular version in the production and you are trying to deploy a new version, you could just try to have the newer version with probably 10% first and see if it works, then slowly increase to 30%, 50%, 90%, and then change to everything to 100%. So that means uh, you could you could choose which version, and sometimes while testing, if the number of percentage of error in the new version, if it is not the beyond so depends on your application type. If you could able to, okay, if I have so many 99.9%, if this happens, I want to keep the latest version, so you can just go switching to the green, otherwise go back to the blue. So you guys are getting a point of canary deployment. Now I want to talk about other things using similar concept. Okay, so smart routing based on user agent header. So for example, we didn't do this, but these are all other things, similar things what you can do just by playing with the virtual services or other similar the YAML file. But what we are trying to say here is Safari only sees v2 response from the recommendations. So if you are trying to make sure through a header, if it comes from Safari, that means only the version 2 should respond. How do you do that? So you could say uh, same virtual service, spec host. When you say HTTP match, you could use the headers, and in the header baggage user agent, you could say reg expression, and you could say Safari. Then you go for the v2. Otherwise, v1. So it's very, so content based routing, you could do it either on the request URL or based on the header things. So that is, you could do canary deployments in a more complex way. So that is one example of it. Okay, we never touch based on what is blue-green deployment. Blue-green deployment is nothing but you you will have only one version, either v1 or v2 in production. But you could send your traffic, when, for example, if you are having a v1 in production, you could send to a mirror version called v2. But the users won't see it, but it's like a parallel send. And through a log file or something, you could watch what will happen, and verify if it is worth. If there is no error, if you could be able to verify that, then you can switch back to green, right? So how do you do that? It's basically a similar approach, HTTP route, right? And while sending to the v2, you have to use a tag called a mirror, and they also call it as a dark launch. That means whenever you say send it to mirror, that means the end user won't see it at all. They didn't even know that there is a newer version you are trying to test with the payload. This is happening behind the scene, and once you are happy, then you switch back from blue to green, right? So the difference between the canary and blue green is, canary, you are trying to distribute the load across different versions, the end user will see that, right? But in blue green, behind this dark launch, the newer version is being tested without knowing to the end user. And once if that is being confirmed, it's fine, then you change into the green deployment. And how do you do is using the mirror tag. The other thing is a rate limiting. For example, to limit the request count rate in a specific microservices in the free tier. Okay. For example, to stop the maximum 5,000 records allowed in a free tier, then charge more, etc. can be done. This is very important because, for example, you start your service for free, and once it becomes popular and so on, you start slowly charging that, right? So you have that using the same kind of a thing. But here we will be using the rule metadata. Okay, and in the rule metadata, you specify something called handler.memquota, right? And the quota specification, you are going to say uh, the request count. Okay, so that means if the number of requests exceeded some limit, you could stop. Basically, you are limiting the service using this uh, rule metadata, right? So I just want to show what are all the powerful things we could do it through the Istio, right? All these are possible because of the Istio, right? So the next one is a fault injection. For example, note that the virtual service provides HTTP fault that will abort the request 50% of the time. So 50% of the time we want to send the 503 error. Can you do that? Yeah, without changing the real service, what you can do is you can say in the same through the virtual service under the HTTP fault, we'll say about HTTP status equal to 503 percentage 50. Otherwise, root destination host recommendation. So that means 50% of the time you get the status of 503, other 50% of the time you get it from the other service. So you don't have to touch your code to simulate this kind of fault injection. Can you do fault injection with a delay? Yeah, sure. Um, so virtual service provides HTTP fault that will delay the request by 50% of the time with a fixed delay of 7 seconds. So same kind of an approach, HTTP fault delay, fixed delay equal to 7 seconds, percentage 50. So 50% of the time you are trying to inject the thing with the fault with the delay of 7 seconds. So retry. So instead of failing immediately, retry the service 10 times, right? So can you do that? Yeah, same thing using the same virtual service, right? Retries, attempts 3, third try timeout 2 seconds, right? That means perform 3 attempts on a recommendation using a timeout of 2 seconds per try, right? So you don't have to touch your service. You could do all these things, right? And can you do a timeout, fault injection timeout? Same thing, virtual service metadata this time, right? And HTTP route and timeout equal to 1 second, right? So gateway timeout error. So 504, you are trying to get the 504 with the timeout. Okay. So now, so we kind of got the glimpse so far. These are all for circuit breaker resiliency strategy. It's very important when the microservices is happening. You want to know whether one microservices is giving some problem, how the other microservices are going to react properly, right? Um, so we don't want to manipulate requests getting queued or marking the instance pod even slower. So we will add a circuit breaker that will open whenever we have more than one request being handled by any instance of pod. Okay. So open means it is going to close means that means it will work. Open means it is going to stop working. So circuit breaker is going to work in a binary mode. Okay. So we are trying to simulate that error. The other error what we are trying to do is pool ejection or router detection is a resiliency strategy that takes place whenever we have a pool of instances to serve the client request. Okay. If the request is forwarded to a certain instance and if it fails, for example, returns a 503 error code during the special endpoint, then Istio will eject this instance from the pool for a certain sleep window, right? So for example, even this is basically to say that the deck of cards thing. So if you have multiple cards arranged and if one card is having a problem, if one card is going to fall, it's going to fall all the 52 cards usually, right? We don't want that kind of cascading of effort on the microservices. So this pool ejection strategy is a very good way to handle if there is any problem with any version of it, it removes from the pool. Okay. So how do you do that? So there is through a destination rule, you could specify a connection pool where HTTP max pending request equal to 1, and you could say outliner detection base ejection time equal to some seconds, right? That means it's going to remove it, eject from the pool whenever it finds a problem with a particular service. So in summary, circuit breaker, which we know what we can do with the circuit breaker, right? Plus pool ejection logic. Just now we saw if there is a problem, we will remove it from the pool. That is also we could do it using the similar Istio way, and the retries which we saw on the previous slide, right? Using circuit breaker, pool ejection, and retry is an ultimate backend resilience. By simply adding a retry configuration to our current route rule, we will be able to get rid of completely our 503 error request, right? So whenever there is a 503 errors, what's going to happen is we could use this pool ejection logic to remove it from, and immediately we'll retry and you will get the response from another pod, right? Which will be a better pod to give the response. So how do you enable the resiliency in the Kubernetes? Is using the circuit breaker, pool ejection, and retrace, and all of these are used based on the Istio metadata, mostly virtual service and destination pool. That's what we saw. And load balancer. So, for example, whenever we say a destination rule, you could say what kind of load balancer you want. You could say random. Okay, by default it is round robin, and if you don't want that to be round robin, you can just change it here. So it's all configurable. Okay, the next important thing what we can do is a mutual transport layer security. So microservices are there, pods are there, and pods will be talking with each other, and while pods talking with each other, you don't want anybody else to see the traffic in the plain text, right? If that is kind of your scenario, mostly see once the Kubernetes is there, you want to make sure it is more secure. So through Istio gateway, you can enable MTLS by applying policy and destination rule. So how do you by do the policy? So it's basically authentication. So there is a authentication.istio.io. Using that, you specify policy and spec is MTLS. Okay. The next one, what he said was applying the destination rule. And in the destination rule, you specify the traffic policy TLS and mode is Istio mutual. So that means between one pod to another pod, the communication is happening through the Istio mutual and through MTLS. So mutual transport layer security. How do you test it? To test these things, we will be using a TCP dump in the terminal to see the encrypted message. We can keep on seeing all these demos, but my point is to show you the beauty of whatever we could do it through Istio. We saw one of the Canary deployment through Istio. The rest of it, what we are seeing is all the other stuff. Okay, so that is what I was trying to cover. One more thing I thought of sharing with you guys is I was trying to change my image after a long time for blue and green messages. Then I observed some of the things. I thought of sharing that with you. Suddenly on Eclipse, it's saying that you have a JRE instead of JDK. So that means it's nothing but you need to add the tools.jar in the JDK path. Okay. So after you choose a JRE, you could add an external jar and you just add the tools.jar. So this JRE error will go away. Another thing what I observed was on the Docker terminal, it was saying that Docker command is not recognized. So all I have to do is just put it in the path. Okay. Then the next one is while building the image, give the SSL encryption. This is the first time I saw this. So need to add the run configuration in the JRE tab. So basically, while trying to run the Ant the Maven target, I need to just make sure add this configuration HTTP protocols TLS v12, then JDK TLS client protocol v12. So yeah, once I did all this, I could able to create the image, and that's the today's demo I showed you guys. So hope you guys understood the power of the Istio. You could do security wise, you could do blue-green deployment or Canary deployment, and beyond that, the circuit breaker, right? Circuit breaker, retries, and pool ejection strategy to get the particular resiliency among the microservices. The issue is the bread and butter. Okay, so that is the today's topic. uh, we'll see in the next video something new. Okay, thanks.